Hi, good afternoon, good morning, and good evening, depending on where you're watching from. Um, in my last video, I was actually doing something on volumetric analysis, and that's titration or what you call quantitative analysis. Okay, here is another question again, similar to the previous one, but there are there's something here that weren't in the one I solved before now. So in case you're just coming to my YouTube channel, you could check it up there. And if you haven't subscribed, kindly do so even now and click the notification button so you'll be notified whenever I upload any new video, either on math, on physics, further math, or chemistry. Thank you for your compliance. Now, what do we have here? We have a question, a practical question, chemistry question called titration question. Now, the question says, A is a solution containing 5.0 gram of hydrogen triazonitrate 5 in 500 cm3 of solution of sodium hydroxide with an unknown concentration of sodium hydroxide unknown concentration. So the concentration of the sodium hydroxide is not known. So we are told to put it into bread and titrate it with, you could say, either 20 or 25 of this, of the portion of B, the base. And of course, being a strong acid and a strong base, methyl orange is fine, it's okay, it's suitable indicator is okay. And so methyl orange will be used. Now, in the previous question, we're asked to write the equation and we're told to balance the equation too. But here, now we are not told that. So we are going to, what we basically do here is that we are going to just look at the equation given to us. It's been given to us, they balanced the equation. The equation is just balanced already, so you could say it yourself. Now, look at the question we are told to find now. We are asked to find the volume of the average used. That's actually the portion A. So I didn't write it there. We are to find the volume of the average, the volume of the acid used. Okay, average volume of the acid used. Now, this is how your table is going to look like. This is how you should prepare your table. In your practical, you have your breath reading, your final reading, your initial reading, and your average volume used. So you could call this your first titration or rough. Some people write rough. I don't know what I used then anyway, I can't remember now. So you can put rough, first reading, second reading. But in this case, we have first, second, third. So the rough or the first reading is assumed that you just approached it casually and you haven't really organized yourself, and so the value will be a little bit different from when you have organized yourself and you are very meticulous. So look at it now. Here we have 16.0. So now let me say this quickly. The acid is put in the bread. The base is put in the pipette. For some person, they will suck it like this. And please make sure you're careful you don't suck the base into to your system. Okay, so the acid is poured in the bread and then the base is poured in the pipette. Okay, so and when you're reading the bread, make sure you read straight to avoid error due to parallax. You read straight, so you're not looking up like this, neither are you looking down. You look straight, and that's will help you to avoid error due to parallax. Okay, now the first reading, the initial reading, that's you have not started anything, 0, and then by the time you put it, you have this. That's your first reading, and then you fill it up again. You fill the billet up again for your first reading or second reading now, and then you got it. You can see the wide difference, so wide. And then the third one, rather than trying to fill it to 0, you could leave it to this point and continue, and then you get this. By the time you check the difference is just the same. it shows you are meticulous. But if you know you're not the careful type in things like this, you could just fill it up to 0 back 0.00, and then you could have 16.12, 16.11, or even 16.10 as the case may be. So the volume of acid used, equals 16.0 plus 15.0 divided by 2. So that will give me 16.0, and I can call that my VA. So my VA, which is the volume of the acid, is this. Okay, now let's move to our next question now. Okay, so I call that the A part of the question. The B part of the question now is a concentration of A in mole per dm³. How do we go about that? If you remember in my last video, I did something similar, so I'm going to do the same now again. Here we're not given any information about sodium hydroxide, the base, so you can't even do anything about that for now. But we are given information about that of the acid, the HNO3, hydrogen triosonitrate 5. We are given the gram, and we're also given the volume, and so we can find the mass concentration in that case. So the mass concentration of HNO3, remember this is the formula I use, and the volume is usually in dm³, not in cm³, in dm³. Please take note. And so the mass is given here as 5.00, and then what happened to the volume here? The volume is cm³, I will convert to dm³. And when you convert this to dm³, what will it be? Since 1 dm³ is 1000 cm³, obviously you know that 500 cm³ will be what? Will be 0.5 dm³. Are you following now? So we have, what do we have now? We have 0.5 dm³, and that will be 10.0 gram per dm³. So that is that. Now, how do I now get my concentration? So my concentration will now be molar concentration, which is molar concentration now. Molar concentration, which is mass concentration over what? Molar mass. And so mass concentration 10, molar concentration of HNO3, molar mass, the molar mass 1, nitrogen is 14, oxygen is 16 times 3, 1 plus 14, 48. You have 63 gram per mole. You divide this by 63, so you're going to have 159 mole per dm³. You could cross-check that. So we come to the second part of the question. The second part of the question is a concentration of this in mole per dm³, and we could now use our favorite formula. You're familiar with this, so every student is familiar with this. Now, so make this subject of formula. You have Ca, Va, and Nb over, what do you have now? Cb and Na. Now we could put the value there quickly, but that may not contain it, and so I may just come and put it here for space sake, or I will push it towards this direction. Please permit me to do that. So I have my Cb equal Cb now equals Ca Va Nb over Cb and Na. So what's my Ca? concentration. That's what I just got now, and that's 0.159. What is my acid? Is on the board already. The volume of the acid, we just did that a while ago, so it's on the board, 0.159. The volume of the acid, 16.1, and then what's the next thing now? That of the mole ratio. The mole ratio of the base is 1 over this. The mole ratio of the base, look at it, 1. Then come to the volume of the base, 25, and this is 1. Now, as you punch calculator now, punching calculator, please, you will not be allowed to do this in the exam or coming with something like this. So by the time you punch your calculator, the volume of the base will be 0.10. What I'm having here is 24. 0.1024 mole per dm cube. So if you take it to be 3 decimal place, it will be 0.12. So that will be the answer in 3 decimal places. So please permit me to wipe the board so as to have enough space to do the solving. So we are told in the third one, concentration of B in gram per dm cube. That's not an issue anymore. That is equals to molar concentration times molar mass. Why did I say that? It's here already. It's here. Look at it. Molar concentration equals to mass concentration over molar mass. And if you make molar mass concentration subject of formula, it gives you molar concentration times molar mass. Okay, so here we have molar concentration of B. We just solved it now, and we arrived at 0.12. The molar mass of B, which is sodium hydroxide. That's not new to us anymore. That's 16 plus 1. That's 40 gram per mole. Per mole, please, sorry. So we have 40. Let's multiply. I believe you are following. 0.102 times 40. Okay, I'm getting 4.08 gram per dm cube. That's what I got here. You can cross check if it's the same thing you're getting there. Now, the next question again, or the last question here, is asking us to find the mass of the sodium triazonitrate form if, please mark this word, of these were neutralized. So the first thing I will do is to find the mole. Mole of sodium hydroxide is equals to molarity, or what you call concentration. Okay, let me not use molarity, not to confuse it. Is equals to concentration in mole by dm cube multiplied by volume. Please know all of this formula. So we have this 102, and then we're multiplying it again. So quickly, 0.102 times 250 divided by 1000. You may ask how? We're given now. Look at it. So I have to convert to DMQ. I told you always in DMQ. Always solve in DMQ. So this is now 250 divided by 100. That will give you 0.24 multiplied by 0.102. Okay, so I have to be meticulous about what I'm doing, and this is what you get. Yes, so this is the mole, but do not forget that we are not told to find the sodium hydroxide. This is the number of mole in there, but from the equation of reaction, if you check the equation of reaction, you will discover that the volume ratio or the mole ratio now is 1:1. So one mole rather of sodium hydroxide liberated 1 mole of sodium trioxonitrate 5. Look at it. Sodium trioxonitrate 5. 1 mole of the base also gave us 1 mole of this. So if 1 mole gave that, it means that what we are saying is that 1 mole of sodium hydroxide liberated 1 mole of sodium. So it means that 0.055 of this will give us 0.055 of sodium trioxonitrate 5. This is so important for you to note. And that, so we mean that we have gotten 0.5 mole of this. Now we are told to find the mass. It is the mass we are looking for. So to find the mass, then we now use a formula that says that mole is mass over molar what? Mass. Mass therefore is mole times molar mass. And so what's the mole? 0.0255. And what is the molar mass now? The molar mass of, please permit me to do it here quickly. 23, 14, 16 times 3. Add this together now. So we have 23 plus 14 plus 48. What do you have? 5 here, 85. So we are multiplying it with 85. So multiply with 85. 0.0255 times 85. Okay, here I am having 2.168. You can cross check over there, gram. And that's the final answer to this question. I'm sure it's pretty simple, right? So you could see how I got number 1, number 2, number 3, number 4. Till I come your way again, I remain my humble self, Yomi Omorewa. God bless you. Bye.